Hi everyone, I welcome you to the presentation of this lecture on the source-free RC circuits. So I would recommend you to watch the previous video where I gave an introduction on the free source RC circuit, and in that lecture I was able to derive the natural response of the voltage. So in this one I'm going to continue deriving some equations. We'll derive an equation for the current passing through a resistor, which is basically the voltage drop across that resistor divided by the resistance itself, which will basically be this. Since we have the voltage equation and the current, we can basically derive the equation for power. So power is the product of voltage and current. Once we multiply those, we are having this, and then it will simplify to that. So this is the power equation. From power, we can also derive the equation for the energy absorbed across the resistor. This one is an integration of power with respect to time. Once we do our integration there and we substitute with T, we are going to have this. That's the energy across the resistor, where tau is basically the time constant, the product of the resistance and the capacitance. This resistor is not a unit resistor, it's the equivalent resistance actually, the addition of all the resistors in the circuit. So from this, let's look at an example. So the question is saying the switch in the circuit below has been closed for a long time and it was opened at that period. So calculate the initial energy stored in the capacitor. So they want the energy which was stored in the capacitor there. Let's look at the solution in the next slide. Okay, so this is the circuit which was given in the question. From here, they want us to calculate the energy. So you can't calculate the energy without knowing the current, or in short, without knowing the power across that circuit. So this power, we'll go through the steps which are introduced in the previous lecture. So at a period where time is before zero, we have an open circuit, which is this one there at the capacitor there. So this is an open circuit. So we can find the voltage drop across that, which is basically the voltage drop across the 9 ohm resistor. So if we use voltage divider rule, the voltage drop across the 9 ohm resistor will basically be this, which is 15 volts. So this 15 volts is the voltage across the capacitor, and it's basically the initial voltage. Since the voltage across the capacitor cannot change instantaneously, we have this, which is the initial voltage. Therefore, at a time which is greater than 0, the circuit changes. So when you open this switch there, it means this voltage source and the resistor will not be in the circuit, and our circuit will remain like that, which is this one here. So from here we can find the equivalent resistor by basically adding these two resistors. When we add those, our equivalent resistor will be 10 ohms. So the time constant is basically the product of the equivalent resistor and the capacitance. We know the capacitance to be this 20 millifarad, which is 20 times 10 to the power negative 3. When you multiply that by the equivalent resistor, we are having 0.2 seconds as the time constant. Then you can use that time constant in that equation. When we do our substitution, we are having that as the voltage. And then we can easily find the energy stored in the capacitor by substituting that value for the voltage in that equation, and this will produce that. So in the next lecture, I'm going to talk about the RL circuit. Thanks for watching.